In this video, I'm going to show you guys how you can solve polynomial equations, kind of putting together all the things we know about factoring, and now about how if we were to graph a polynomial function, knowing how the graph intersects the x-axis tells us a little bit about the roots or zeros of the function. What I'm going to do is go through 4 examples with you guys and try to explain in detail how I would go about solving each of them, so you get a little bit of a taste for how you can go about solving these things, and hopefully feel pretty confident that you can go ahead and try a few on your own after watching this. So for the first example, you always want to make sure that you're, number one, that you're set equal to 0, and I am. And you also then would want to make sure that your polynomial is written in standard form from highest to lowest exponent. And in this case it is. Now, if I can, I'm going to try to factor, because factoring actually is going to be a lot quicker and easier than anything else. Now, the first rule of factoring is to look for a GCF that is in every single term. And in this case, I get lucky. Each of those 4 terms has an x in it, so I can factor an x out. And if I do, I'll be left behind with an x cubed plus 6x squareds plus 12x plus 8. So right now, as it is, I have it factored down to the product of x times this long cubic polynomial. So as it is, I know x equals 0 from this factor is one solution. Now also keep in mind, the fundamental theorem of algebra says, since this is a degree 4 polynomial, right, my degree is 4, I expect 4 total solutions, right? So let's keep that in mind. Right now I know one of them, that's great. The other 3 of the solutions are locked inside of this cubic polynomial here. So now my job is to find out, when does x cubed plus 6x squared plus 12x plus 8 equal 0? Now, you might be thinking, well, maybe we can factor this by grouping, and I would agree that since there's 4 terms here, grouping is a great idea. But I think if you pair these 2 together and you pull out the GCF of x squared, you'd be left with x plus 6. Unfortunately, if you pair these 2 and pull out the GCF of a 4, you'd be left with 3x plus 2, and these 2 binomials do not match. So we're kind of stuck. We cannot factor by grouping. What I would have to do at this point, since I can't factor this remaining cubic polynomial, what I'm going to do is I'm going to plug this cubic polynomial into my calculator to graph. And so what I'm going to do in a second here is I'm going to change screens, and I'm going to pull up a calculator, and I'd like to get your calculator out and ready so you can kind of follow along with what I'm about to show you on the calculator. Let's see if I can do this. I'm going to switch over to my calculator here, and hopefully this works. So I'm going to turn my calculator on, and in for y equals, I'm going to type in that cubic polynomial, and I think it was x to the third. Now to get x to the third, guys, what you have to do is hit, right next to the green alpha key, you're going to see a button that says x comma t comma, and then it looks like a circle with a line through it. That's a theta button, or your variable button. So you're going to go ahead and hit that, and you should see an x pop up. So we want to raise x to the third, so I'm going to hit the caret symbol, so go x cubed, and then I want to do plus 6x squared, so I'm going to type in plus 6, hit the x symbol again, and the square, you can just hit the x squared button, that's to the kind of upper left corner where the number 7 is, or right above the log button. So I have x cubed plus 6x squared, and then it was to be plus 12x, and then plus 8. So that's my polynomial I want to graph. Now, a couple of things, guys. When we graph, we want to graph in the standard window. Now, let me describe a few things when we do this. To easily get to the standard window, Do you see right in the middle of the top row of buttons there's a zoom button? It's kind of like a skinny long button, 2 buttons to the right of y equals. If you hit zoom, it'll take you to the screen. And what I'd like you to do is, if you go down to option number 6, that's the zoom standard window. And I'll explain that. I want you to just go down to 6, or just type the number 6 and hit enter. And what's going to happen is the calculator is going to automatically graph your function in the standard window. Now, I'm going to go ahead and kind of draw on this for a second to explain a couple of things about what this means with the standard window. Okay, now if you're in the standard window, what that means is all the way here on, let me change colors here, all the way here on the right side of your screen, this only goes so far as an x value of positive 10, and the left side of your screen only goes as far as to show you an x value of negative 10. So it's like your x-axis goes from negative 10 to 10, and the top of your screen, it doesn't go, to infinity. It's got to cut it off somewhere. This is going to a y value of positive 10, and the bottom of your screen goes to a y value of negative 10. So we're just taking kind of a snapshot, if you will, of this graph from negative 10 to 10 on both the x and the y-axis. And if you look closely, each of those little marks that you see on the x and the y-axis represent 1 unit. They're counting by ones. So we don't want to actually see the grid like a graph paper, otherwise it would be too messy, but this is a pretty good picture. Now you can see, if you look carefully at how your graph intersects the x-axis, let me erase the stuff that I just wrote on there, if I could. If you take a careful look at how your graph intersects the x-axis right here, something special is going on. The graph does not just cut right through the x-axis. If you remember from the previous video, that looks like it's flattening out, it's kissing the x-axis, and then it's going through. This is the classic kiss and go. If you have a kiss and go, remember there's an odd number of solutions there. Meaning, it doesn't just intersect the x-axis and have one solution there. It's going to have to be either 3 or 5 or 7 or 9 or any number of odd number of repeated solutions. Now, just eyeballing this, it looks to me that it hits the x-axis at negative, let's see, this is like negative 1 here, this is negative 2. It looks like negative 2 to me is where it hits. So my guess is that it's at negative 2. If I want to really guess that, the way you're going to do that, guys, is you're going to hit the trace button and type in the number you'd like to guess, like negative 2. So when I do that, all the stuff that I just wrote is going to disappear for a second, and that's okay. So when I do this, let me see if I can pull this back on again. If you hit trace, you should see this, and then if you just type in what you want to guess, like negative 2 as your solution, you'll see that negative 2 pop up on the bottom left of your screen, and then when you hit enter, it takes you wherever on the graph gives you the x value of negative 2. And you'll notice it tells you that the y coordinate is 0, which is great news. That means negative 2 is a 0. It gives an output of 0. So I know a few things now. If I go back to my screen, let me go to my previous page if I could here. Let me see if I can do it. Please work. Oh no, it's not letting me go back to my original screen here. I guess I'll just continue from here if that's okay. If you remember, I think our first solution was 0, and then we had to find 3 more solutions in our polynomial. Well, we have them. We know there's not just one solution at negative 2. It's going to be an odd number of repeated solutions, so it's going to have to be 3 zeros at negative 2. And I don't have any more work to do. Here are all 4 solutions for the problem that we've just done. I'm going to go ahead and show you another example now on how we can use our calculators to help us solve. So let me see if I can go back to chalkboard here. Let's come up with another problem. Let's look at this one. Let me get my white chalkboard. Let's do yellow in this one. So let's call this example 2. Let's do x cubed minus 9x squared minus 11x plus 87 equals 0. Okay. Now as I look at this, there is no GCF for factoring, and I don't think we're going to be able to factor that one by grouping, guys. I mean, I can't even pull out a GCF from 11 and 87, so I don't think I can factor that. What I'm going to do is right away I'm going to pull up my calculator and see what kind of goodness I can get from graphing it. So let me see if I can pull that up again. Here's my calculator, and to put in the new equation, just hit the y equals button, clear out the old problem, and let's type in x to the third. So x caret 3, oops, caret didn't really show up there, x caret 3 minus 9x squared, minus 9x squared, minus 11x, and then plus 87. Now, I'm going to hit zoom 6, so I'm just going to type the number 6, and it's going to graph it in the standard window, and I get all this crazy business right now. So let me explain what's going on here. Let me get into my drawing mode and explain a couple of things. First of all, it looks like there's 3 lines, and this doesn't look like a polynomial. It looks like, what in the world is going on? And I would agree with you. It is a little scary looking. But keep in mind, guys, this is a polynomial function that's a smooth curve. What really is going on, if you think about it, if we just sketched our end behavior for a second of this graph, because it's an odd degree and it's positive, remember what we learned about every end behavior? The graph goes up and to the right and down and to the left. Now, that is happening here, but there could be a lot of different things going on. There could be a lot of little wiggles in there and so on. I think what we're seeing right now is only a part of the graph. Really what's going on is this, what appears to be a line, goes down forever this way, right? And it probably goes up and like that, connects, goes down, and then goes like this, and then goes up and goes on forever. So it follows this end behavior, but all we're seeing is like a little snapshot of this window. And what's really kind of good is you don't have to mess around with your viewing window to get like the greatest picture in the world, because we're not really, the purpose of what we're doing here, guys, is we're not graphing, right? What I want to know is, where are these solutions? And actually, these are not any kind of fancy intersections. All 3 are cuts. These are 3 cuts, meaning each one of these is one of the solutions. And remember, it was a degree 3, so here are all the solutions. If I can just get those, I'll be in great shape. Now, the bad news on this, if you look carefully, it looks like this might hit over here at -3, but it doesn't look totally like it hits at -3. This looks like it might be at 3, and this is 4, 5, 6, 7, 8, 9. This looks like it's at 9, but I don't think it's going to hit there. Let's see if we can kind of use the trace feature and see if we get lucky. Maybe the solutions are -3, 3, and 9. Well, let's give it a try. I'm going to exit the drawing, and I'm going to go back here. If I hit trace and type in -3 and hit enter, when I hit -3, my y value is 12. It's not 0. So -3 is not a solution, unfortunately. That must be some kind of strange decimal really close to -3. Let's try 3 though. If you just type 3 and hit enter, you get 0. So now I know 3 is a solution, which is fantastic. Let's see if 9 is. If I hit 9, I get -12, not 0. So from the graph, unfortunately, all I can see right now is that one solution is definitely 3, and then these must be some kind of decimals. They might even be irrational solutions. And I want to find the exact value. So I'm going to show you how you can do that, knowing only one of the solutions is 3. So I'm going to kind of go back to the drawing board on this problem. Let's see if I can do that here. Boom. No, it's not letting me. Let's go to the chalkboard. And let me get back to my color. So we know that x equals 3 is one solution. And remember, the original problem was x cubed minus 9x squared minus 11x plus 87. Remember what we did? If I knew one solution in the previous section, I can synthetic divide that out, and I can try to find the remaining factor of the polynomial, and that's all I'm going to do now. So since I know 3 is a solution, I'm going to do synthetic division, and I think I have all the terms of the polynomial. It's 1, negative 9, negative 11, and 87. And the good news is, if I do this right, I better get a 0 at the end, because this is supposed to be a 0. If I drop down the 1 and multiply 3, I get that. If I add, I get negative 6. If I multiply 3 and negative 6, I get negative 18. If I add those, I get I get negative, what is that, 29. And if you do 3 times negative 29, that is negative 87. And when you add those, you get 0. So that's great news. This is my remaining factor, and remember, this is my constant, this is my x coefficient, this is x squared, so really the remaining factor is x squared minus 6x minus 29 equals 0. Now to solve this, to get the other zeros, and those ugly decimals, right, I'm going to have to either use completing the square or the quadratic formula. I suggest using the quadratic formula. So my a value is 1, my b value is negative 6, my c value is negative 29. So if I do this, it's going to be the opposite of b, so minus negative 6 plus or minus the square root, negative 6 squared, minus 4 times the a value times the c value, negative 29. All of that has got to be over 2 times the a value, which is 1. So let's see if we can clean this up. Minus negative 6 is positive 6, plus or minus the square root of negative 6 squared is 36, and then minus 4 times 1 times negative 29. Let's see, so it's like 4 times 29, I know it's going to be a positive, and 4 times 30 is 120, but it's not 4 times 30, it's 4 times 29, so it's really going to be 4 less than that. So instead of being 120, I think it's going to be 116 if you multiply those. And let's see, that's going to be all over 2, so I end up with 6 plus or minus the square root of 36 plus 116. What is that going to be? That's going to be 12, carry the 1, 3, 5, 152 over 2. And now it's just a matter of simplifying the radical, unfortunately. So let's see. If I take a 2 out of 152, I think that's going to be 176, so, or it's just 76 rather. And then I can take another 2 out of that, which would leave behind, let's see, 38. So, and then 38, I can take another, take another 2 out of that, and that would be a 19. So at the end of the day, I have a pair of 2's I can pull out, and I'm going to be left with the square root of 38. So, let's see if we can simplify this ugly guy. We have 6 plus or minus 2 square root 38, all of that over 2. Now I can simplify 6 over 2 plus or minus 2 rad 38 over 2. 6 over 2 is 3, plus or minus, these 2's cancel, root 38. So the other 2 solutions to this problem that my calculator couldn't give me that were irrational were actually 3 plus the square root of 38 and 3 minus the square root of 38. And I bet you, if you put this into your calculator, and it might be interesting to see, I bet you that's pretty close to 9. Remember where it looked like it was hitting close to 9? And I bet if you put that in your calculator, that's probably pretty close to negative 3. But again, it wasn't giving it to us in a calculator because these really are the answers. I mean, those are the exact values without like rounding and getting ugly decimals. So there's your 3 solutions. I think what I'm going to do is I'm going to stop this video. I'm going to make another maybe video or two and just have a few more examples for you if you'd like to watch. Thank you for watching this one. See you tomorrow.